You guys did good on this. So you wrote the explicit formula, a sub n is equal to a sub 1, which was 3, plus n minus 1 times the common difference, which was 3. Then that would be, so if I said write the simplified formula, you would distribute that through. So that's why you had 3 plus 3n minus 3, which was awesome because you wrote a sub n is equal to 3n. Perfect, very good. That formula allows you to easily find any term in the sequence, so you plugged in 63. So a sub 63, the 63rd term, would be 3 times 63, which is 198. Awesome. Way to go, really good. Okay, we're going to be doing this same thing. Oh, yeah. I was walking around and saw, and I got that a little bit backwards, those two numbers. Okay. That's what it is, really. 189. Very good. Good catch. All right, let's do 11-2. So you have your formula sheet out. Please get that out just because you need to be getting comfortable with that formula sheet. So we were given the formula at the top of the worksheet last time. That was the explicit formula for a geometric sequence, and we'll leave that formula worksheet today. So today we're going to be doing did I just say geometric? I did? Okay, it's supposed to be arithmetic. Sorry, arithmetic sequence. Today what we're doing is geometric sequences. So now it's no longer arithmetic. There's not going to be a common difference. It's going to be geometric. So similar to an arithmetic sequence, geometric sequences have a pattern. Between each term, there's a pattern. But an arithmetic sequence, between each term, there is a common difference. That means if you subtract the terms, it's the same every time. Whereas in a geometric sequence, there'll be what's called a common ratio. Now ratio, remember what the word ratio means? Ratio means division. So what we're going to do is we're not going to say, okay, every time we're multiplying by something, we're going to actually do it a little bit backwards. We're going to divide. So for example, right here, this is an arithmetic sequence because there's a common difference. And make sure we do the difference. 8 minus 6 is 2, 6 minus 4 is 2, 4 minus 2 is 2. It has a common difference, so it's arithmetic. Now with this one, it's geometric because there's a common ratio, meaning 27 divided by 9 is 3, 9 divided by 3 is 3, 3 divided by 1 is 3. So we're timesing by 3 each time. Our common ratio is 3. That's what makes it geometric. There are sequences that are arithmetic, there are sequences that are geometric, there are sequences that are not either. They're neither arithmetic or geometric because they don't have a common difference or they don't have a common ratio. Alright, so what I want you to do is go to your worksheet, do problems 1 through 9. So you're just going to tell me, is the sequence geometric? Yes or no? And if not, if it is, then tell me the common ratio. Ready, set. Okay, so now we know that we don't want to have to go through, and if I say find the 100th term, you don't want to have to go through and multiply by, for example, 2 till you get to the 100th term. That would take you too long. So that's why we're just like with an arithmetic sequence, we're going to write an explicit formula that allows us to find any term in the sequence. So this is the general formula to find any term in the sequence for a geometric sequence. So a sub n means any term in the sequence will be equal to a sub 1, the first term, times by the common ratio raised to the n minus 1, where n is the nth term you're looking at. 100, if you're looking for the 100th term, you'd plug in 100, right? So that formula is what's the most usable formula. That's why I put a smiley face. We like explicit formulas because you don't need to know anything besides the first term and the common ratio. But we do need to be able to write a recursive formula in case it asks us. So the recursive formula is easier to write because it's very just intuition. Like it's like, what are you doing to get from one term to the next? Well, we take the previous term and we multiply it by 2 every time. It's not like, it's very straightforward. It's just not as usable to find any term in the sequence. So that's why I put this I didn't put a frowny face because it's not a bad thing. It's just kind of like So anyways, a sub n is equal to a sub n minus 1. Now remember what that really means. If I ever see that a sub n minus 1, it literally just means the previous term. You take the previous term and you times it by the common ratio. So if I had 2, 4, 6, 8. My recursive formula would be a sub n minus 1, and then we're timesing by 2. So times by 2. That's how easy that is. You take the previous term and multiply it by 2. That would be our general formula here. Not very usable. If I say find the 100th term, you would need to know the 99th term. So that's why it's not usable. All right, here we go. Let's practice this. Notice you have that formula written down for you on your sheet. Locate that. Yeah, perfect. Okay. So I'm just going to have you look up here before you get started. Let's do this. So it says write an explicit formula and write a recursive formula for the geometric sequence. So let's see what the common ratio is. That divided by that is -2. That divided by that is -2. That divided by that is -2. Now I want you to notice something with this sequence. Do you see how we're bouncing back and forth between positives and negatives? That makes sense, right? Because if you take a positive times by a negative, it's negative. But now we multiply by -2 again, it makes it positive. So that happens with geometric. Okay, so our common ratio is -2. So we would write our explicit formula. A sub n is equal to a sub 1, which is 2, times by our common ratio, which is -2, raised to the n minus 1. Now I want to ask you a very important question, and let's see if you remember with exponentials. Would it be appropriate to take 2 times -2? No, very good, because this 2 is not raised to n minus 1. So this is a simplified form here. Everybody understand? Perfect. So now recursive formula is the easy one to write. It's just not usable really. A sub n minus 1 means you take the previous term and you multiply it by -2. So times by -2. That's my recursive formula. Very easy to write, just not very usable. This would be the one we want to use. If I said find the 100th term, you would do a sub 100 is equal to 2 times -2 to the 100 minus 1. So that's really 2 times -2 to the 99th power, and you would just type it into your calculator. Awesome. So find the 40th term of the geometric sequence. Let's do this really quick here. So 27 divided by 9 is 3. 9 divided by 3 is 3. So we would say a sub, let's just plug it directly in. A sub 40, correct? Equals our first term would be 3, and then our common ratio is 3 raised to the 40 minus 1. So we would have 3 times 3 raised to the 39th power. Will you hurry and type that in for me just so I can finish it off? You've got to use parentheses, guys, just like you see it. Does it E? Does it say E? Okay, so we've got to make sure to write that, because I was like, I noticed that was weird because it was getting larger. Does that make sense? So it's getting so large by the 40th term because we're multiplying by 3 that it's writing it in scientific notation. So sorry, say that one more time. 1 point times 10 to the 19th. So writing that out would be like in the thousand. I mean, like whatever. We'd have to pick, you know what I mean? So that's fine. Just don't forget to write that. Okay. Awesome. So ready, set, go. So we're trying to find a missing term. There's 2 ways to do this. So the first way is to say, okay, because we don't, like 4 times something equals 16. Isn't that true? So you could do this 2 different ways. You could do it like that. You could say, so 4 times something equals that, times that something again equals that. So my true statement would be 4 times question mark times question mark will be equal to 16. Does everybody see how that's a true statement? 4 times something again will equal 16. Okay, so now let's solve for question mark. So we divide by 4, so we have question mark squared, don't we? Question mark times question mark is question mark squared. Equals divide by 4 to both sides, so we would get 4. How do we solve for question mark? Good, square root both sides. So question mark is equal to, what else could it be? It could be plus or minus 2. We really don't know, correct? Because think about it. So now we know question mark is, let's say it's positive 2. What's 4 times 2? 8. Then times 2 is 16. Let's see if negative 2 works. 4 times negative 2 is negative 8 times negative 2 is 16. So do you see how either or could be the answer? We don't know. So you have to list out both of those answers. Plus or minus 8. The second way is to simply just set your, this is the way I do it, okay? But there's validity in all of these because if you get to a more advanced problem, way number 2 won't work. Because we're dealing with this, we don't know this is what this is, we could just call it x. So let's set up a true statement. Isn't it true to say 16 divided by x will be equal to x divided by 4? Right? You do it this way, this divided by this will be the same as this divided by this, which will be the same as this divided by this, and so on. So it's true to say 16 divided by x, this is really the easier way, equals x divided by 4. Now let's solve for x. So we'd cross multiply or get a common denominator, right, everybody, technically? So we'd multiply by x, but our x's divide out. We'd multiply by 4 times 4, but our 4's divide out. What's 16 times 4, somebody? 64 equals x squared. Square root both sides, so x is equal to plus or minus 8. You see how we got the same answer, it's just getting there differently. Okay, so our answer was plus or minus 8. In there was plus or minus 8. We've already listed that out. So I'm going to do number 21 the easy way. I think the second way is easier, because then you're just directly solving for x. So you can do it either way. So I'm going to call this x, and I'm going to set up a true statement. 16 divided by x will be equal to x divided by 9. Anytime you're asked to solve for something and you don't know how to do it, you just set yourself up a true statement. So we'd cross multiply. What's 16 times 9? The 9 will divide out over here. Someone? 9 times 16? 144. Okay, cool. And then we multiply both sides by x, but it divides out over here, so that's why I'm not writing it. Or we're cross multiplying. Equals x squared. We square root both sides, so x is equal to plus or minus 12. So it could be plus or minus 12. Questions? That's cool finding, just so you know, because if they say to you find the geometric mean, that's what it's going to be talking about, is doing it this way. Anyways. The geometric average. Okay, so do 20 through 28, ready, set, go. Let's see if we can think through how to do a harder one. If I said to you, find the missing pieces here, you couldn't do it with the geometric mean because we're missing 2 spaces here. You have to set yourself up the first way, you know how I taught you the first way, way number 1. So let's be careful though, what would my true statement be? 2 times something, right? 2 times something equals that, correct? I should draw myself a picture so I get enough somethings. Then that times something equals that. Then that times something again equals that. So my true statement is 2 times question mark times question mark times question mark equals 16. So everybody see how to do this? So then that would be 2 question mark cubed equals 16. So then you would divide by 2. So question mark cubed equals 8. So then we cube root both sides on this one. Does that make sense, everybody? So the cube root of that would be question mark equals positive 2. Isn't the cube root only one answer? Positive or negative? Perfect. So my answer would be, so question mark's 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So then we would just put that in on the test. Okay, here we go, 38. Write an explicit formula for each sequence and generate the first 5 terms. So here we go. We are writing a sub n is equal to a sub 1 is 3 times by our ratio, which is negative 2, raised to the n minus 1. There's our general formula that will allow us to find any term in the sequence. So now we can just do this since it says find the first 5 terms. Those are the easiest ones, right? We could either plug in a sub 1, we could plug in a 1 here, plug in a 2, or we could just do it the easy way. So isn't the easy way to just say if a sub 1 is 3, we're multiplying by negative 2 each time. 3 times negative 2 is times negative 2 times negative 2 times negative 2. 48, it should be bouncing between positive and negative because that makes sense. If it's a negative ratio, it will. Awesome. That's how you do those. And then let's go to 48. So we're almost done here, and then the rest of the time will be yours to finish up. So let's go to 48 real quick. It says, you enlarge the dimensions of a picture 150% several times. after the first increase, the picture is 1 inch wide. It says write an explicit formula to model the width after each increase. Okay, so here's the thing, guys. Our A sub 1, it says the first increase, and I really kind of thought really hard about this one. I was like, well, after the first, does that mean we started with something smaller? But don't overthink it. After the first, so our first one is 1 inch. A sub 1 is 1 inch. Does that make sense, everybody? So now we're going to write an explicit formula, A sub n, and then, our ratio is a percent in this one, but we need to write it as a decimal, correct? Like when we're doing math, if I said find 60% of this, you wouldn't type in 60%, you would type in 0.60. So does everybody understand, like whenever you're doing a percent in math, you have to do decimals. So what would that be as a decimal, anyone? Good, 1.5, 150, 100% of its worth plus 50% more. So A sub n is equal to A sub 1, which is 1 inch, times 1.5 raised to the n minus 1. Okay, now it says, how wide is the photo after the second increase? So like to me, it's just easier to just actually multiply or to type in, well, we could just type in 2. So that would be 1 times 1.5 raised to the 2 minus 1. So 1 times 1.5, right? Because 2 minus 1 is 1. That becomes a 1. So 1.5 to the first is just 1.5. 1.5 times 1 is 1.5. So it's 1.5 inches. It says, how wide is the photo after the third increase? So we'd be doing 1 times 1.5 and then 3 minus 1, which that would become a 2. So you type in your calculator, 1 parenthesis 1.5 squared, and you would get 2.25 inches. How wide is the photo after the 12th? You'd plug in a 12. 1 times 1.5 raised to the 12 minus 1. So that would become 11. So you type in 1 times 1.5 to the 11th. And that is 86.5 inches large. So you only change it to something different if it's a percent. So if it says to you, it's 2 times larger, you just use a 2. That's not a percent. Everybody good? Okay, awesome. So I'm going to have you finish the worksheet now.